when I'm drawing a linked list, remember it has two parts. One is for the data, where you put the data inside, and the other one is where you store the memory address. Now this block itself, this entire block, let me change my marker. Okay, so from here till here, right, this entire thing is called a node. Then we have, when this node, okay, a linked list basically, if it has a single address block and a single data placeholder, then it's called a singly linked list. Okay, and there's of course a link between the two. Okay, so this is a singly linked list. The first node, okay, the first one is called the head, and the last one is called the tail. Then the middle one is not going to be the tail, the last one is going to be the tail. Okay, so the last node is called the tail, the first node is called the head, and the tail always has null inside of it here in the memory block, because it's not pointing to something else, so that's why it's null. Just remember that this is an example or the characteristic of a singly linked list. Next we have another type of linked list. It's similar to the singly linked list, except that it has two placeholders. Now this looks a bit strange. I don't want you to get confused, but I'll tell you what this is. The first one, okay, so we have the first block here, this is for the memory, and the last block is also for the memory. The block in the middle is for the data. So why do we have two blocks for memory? Because this block, right, it contains the memory address of the next block, but the first memory block contains the address of the previous one. Okay, so basically remember we had the singly linked list, it's only has the address of the consecutive or the next block. This one contains of both the next one and the previous one. So this type of linked list is called a doubly linked list. That's gonna write it over here. And as usual, the last node is the tail, the first node is the head, and the characteristic of this doubly linked list is that the last one, you know, this last memory block of the tail has a null, and the first one also has a null, because I mean there's nothing previous or prior to the first node, so that's why it's null, and there's nothing after the last node, that's why it's null. Okay, so this is a doubly linked list. Then we have a third type. Okay, the third type is called a circular linked list. This is a circular linked list. What makes it circular is that the last node, remember in my diagram here, actually not this one, this one, the last node contained null in the singly linked list. In a circular linked list, it doesn't contain null. What it does is that it points to, or it contains the address of the head node, so it links back to here. So if you were to come after this, if you say I'm at head right now and then I want to go to the next node, it's going to take you to this second node, to the tail, and then if you want to go next again, it's not going to be null, it's going to take you back to the head because it's circular. Okay, so that's something about a circular singly linked list. In a doubly circular linked list, what happens is that this, remember I told you that tail contains null. In this case it's not going to contain null, it's going to also point back to the head, and the head's previous is going to point back to the tail. See, so that's just the difference. Circular doubly linked list, circular singly linked list, and a normal traditional non-circular singly linked list and a normal doubly linked list. That's just the different types of linked lists you can get.